Root cause analysis is a technique that helps us to determine what the real problem is and not just the symptom. Now, the tool we will be looking at now has a number of different names. Within the title of this video lecture, we are calling this technique a fishbone diagram, but it's also called a cause and effect diagram or an Ishikawa diagram. Karuru Ishikawa developed this concept in 1968, but the basic concept was first used in the 1920s and is considered one of the 7 basic tools of quality control. We will cover the other 6 in this quality management section. Why it's also called a fishbone diagram, I think you can guess. What is interesting is that we find the use of the technique in both quality management and product design. This is an important point. Very often one can use techniques for various purposes, and I encourage you to try certain tools in different ways. You might be surprised with the results. What you see on the screen right now is an example of a fishbone diagram. You will see the classic elements that are covered within this technique, covering machine, material, measurement, and method. And these elements should be focused on the characteristic or problem. You usually don't use this technique by yourself, but rather more in a group situation. Since this exercise requires us to be somewhat creative, we very often bring subject matter experts together to perform some sort of brainstorming. In addition, the diagram serves as a map illustrating possible cause and effect relationships. Simple steps to developing a cause and effect diagram. Ensure the issue or problem under discussion is captured in the box at the top of the diagram. From the box, draw a line running across the paper to form the spine of the fishbone. From the spine, draw diagonal lines to represent classes of potential causes of the problem. These classes may include policies, processes, people, and tools. To represent deeper causes of a problem, draw smaller lines. Think about the classes and the potential causes of the problem, and then capture them under the suitable class. Examine the results. It is important to remember that this helps in identifying not only potential causes of the problem, but also is used to validate the real cause. Further analysis will probably be required after that regardless. I'm afraid this part can't be escaped. Think about possible solutions once the real cause has been identified. I hope you found this description useful. Get ready because we are about to move on to the next video lecture. So I hope you're buckled up.